Fuels and lubricants. Hello everyone, welcome to today's lesson on fuels and lubricants. In this video, we will learn about the definition of fuel, its classification, desirable properties, calorific value, types of coal, petroleum refining, and lubricants. Fuel is a substance that produces heat energy when it is burned. It mainly contains carbon and hydrogen. During combustion, fuel releases energy, which can be converted into useful mechanical work. Fuels play an important role in engineering because they are used for running engines, generating electricity, and powering industrial processes. Fuels are classified into three categories. The first category is solid fuels, which include coal, wood, and coke. The second category is liquid fuels, which include petrol, diesel, and kerosene. The third category is gaseous fuels, which include natural gas, LPG, and hydrogen. A good fuel should possess several desirable properties. It should have a high calorific value, ignite easily, and burn in a controlled manner. It should contain low moisture, be non-corrosive, safe to store and transport, economical, and easily available. Now let us understand the calorific value of fuel. Calorific value is the amount of heat energy released when 1 kilogram of solid or liquid fuel, or 1 cubic meter of gaseous fuel, is completely burned. It is expressed in kilojoules per kilogram or kilojoules per cubic meter. There are two types of calorific value. The first is higher calorific value, also called HCV. It is the total amount of heat produced when the fuel is completely burned and the water formed during combustion is condensed. It includes the latent heat of vaporization and represents the maximum energy that can be obtained from the fuel. The second is lower calorific value, also called LCV. It is the amount of heat produced when the water formed during combustion remains in the form of vapor. Since the latent heat is not recovered, LCV is always lower than HCV. The relationship between the two is given by the equation LCV equals HCV minus 0.09, H multiplied by 587, where H is the percentage of hydrogen present in the fuel. The essential properties of a good fuel include high calorific value, moderate ignition temperature, controlled combustion, low moisture content, non-corrosive nature, safe storage and transportation, economical availability, and low ash content. An ideal fuel should provide maximum energy efficiently. It should ignite easily but should not ignite spontaneously. It should burn smoothly without excessive smoke or explosions. It should have low moisture content, should not corrode equipment, should be easy to handle and transport, should be cost-effective, should leave very little residue after combustion, and should be environmentally friendly. Now let us study the bomb calorimeter. A bomb calorimeter is used to determine the calorific value of solid and liquid fuels. It consists of a strong steel vessel called the bomb, which contains the fuel sample and oxygen. When the fuel burns, the heat produced is absorbed by the surrounding water. The rise in temperature is measured, and from this, the calorific value of the fuel is calculated. For gaseous fuels, a Boy's calorimeter is used. In this instrument, the gas burns inside a combustion chamber while water flows around it and absorbs the heat produced. The increase in water temperature is measured to determine the calorific value of the gaseous fuel. Coal is classified into four main types. The first is peat, which has the lowest carbon content and the lowest calorific value. The second is lignite, which has a medium carbon content and is commonly used for power generation. The third is bituminous coal, which has a high carbon content and is widely used in industries and electricity generation. The fourth is anthracite, which has the highest carbon content and the highest calorific value, making it the best quality coal. As we move from peat to anthracite, both the carbon content and the calorific value increase. Coal analysis helps determine the quality and suitability of coal. Proximate analysis includes the determination of moisture, volatile matter, ash, and fixed carbon. Ultimate analysis determines the percentage of carbon, hydrogen, nitrogen, oxygen, sulfur, and ash present in the coal. Liquid fuels are obtained from petroleum. Common examples include petrol, diesel, kerosene, and fuel oil. These fuels have high calorific value, burn cleanly, and are easy to store and transport. However, they are relatively expensive and contribute to environmental pollution. Petroleum refining is carried out by fractional distillation. During this process, crude oil is heated and different fractions are separated according to their boiling points. The products obtained include petroleum gas, petrol, kerosene, diesel, lubricating oil, fuel oil, and asphalt. Definition. Finally, let us discuss lubricants. Lubricants are substances used to reduce friction, wear, and tear between moving parts of machines. They form a thin protective film between the surfaces in contact, ensuring smooth operation. Types of lubricants: liquid lubricants, oils, mineral oils, vegetable oils, synthetic oils, semi-solid. Lubricants, greases, lubricating oil plus soap plus thickener. Solid lubricants, graphite molybdenum, disulfide, MOS2, PTFE, Teflon. Gas lubricants, air steam used in high-speed applications. Functions of lubricants: reduce friction, reduce wear and tear. Reduce heat generated due to friction, increase the efficiency and life of machines.